Good evening once again. I don't feel comfortable leaving you guys off with just one example of actually solving these kind of problems, these polynomial inequalities. So I'm gonna do a couple more just so you guys have more of an idea. All right, here we go. Now remember, the last time we left off here, and I did some of it for you. So for the most part, what ends up happening is based on our polynomial. Well, actually, you know what? Let me switch this to a highlighter real quick. When we were solving this polynomial inequality, the first thing we had to find was the critical values. We found the critical values by just solving it as a polynomial equation, and those became our critical values. From there, we developed a sign chart. Based off of our 3, -2, we have we developed the notches in our sign chart. So we have 3 sections. We have all the numbers that are less than -2, all the numbers in between -2 and -3, and all the numbers after -3. So what we did was we picked 3 numbers. We picked 3 numbers to go in those, right? So after we picked those numbers, we found out we got a plus, minus, plus, right? So then after we got that, we saw the intervals. Since this is saying that this polynomial is greater than 0, that means that polynomial is positive. So all we care about are the positive intervals. So really, this is going to be positive in this interval. So basically, that means it's going to be positive when x is less than -2 and when x is greater than 3. So with that being said, as long as x is one or the other, that's how we get this interval here. So when x is less than -2 or x is greater than 3, that we have our solution set. And then here's just the graph of it. All right, so we got that part. So let's do another one just to make sure that we really got this good. All right, first off, here we're doing 3t is less than 4 minus t squared. So let's solve and make this a polynomial inequality. Let's see. What I'll do is I'll take this t squared and this 4 over to the other side, and I should end up with t squared plus 3t minus 4 is less than 0. All right, so I have that. Now let me go off to the side. I can find my critical values. With my critical values, I have t squared plus 3t minus 4 equals 0. All right. If I factor that, I have a t here, a t here. I'm going to put a 1 and a 4. Reason why? Because I need 3t. So if that's the case, this sign right here tells me that they're different. That goes to the larger number. So that's a plus. That's a minus. With that, t minus 1 equals 0. And t plus 4 equals 0. So with that being said, we have these two values. So our solution set is going to be -4, 1. And bam, that's our solution set. So from here, we develop a sign chart. With our sign chart, let's make one real quick. It's going to look a little like this. Let's put my -4 here. Let's put my 1 here. And what I have to do is I have to choose values in between these two critical values. So let me change my, let me just change my color just so we can figure out our color. All right, over here, I need a value less than -4. So I'll choose -5. Now remember, this is just like a number line, and these are like big notches on the number line. So we'll choose that. Between -4 and 1, I'm going to choose 0. If I could choose 0, I'm going to choose 0 because 0 is the easiest number to plug into anything. And then from here, I'll use 2. So from here, we got to find out what happens when I plug those numbers in. All right, when I plug -5 in for t, or plug -5 into my function, I'm going to end up with 5 squared, which is 25, plus 15 minus 4, which is, I don't need to looking at it, I can tell that's going to be positive, right? From there, let's try to plug in 0 and see what we get. If in fact I plugged in 0, this is going to be 0 plus 0 minus 4, which is going to be negative, right? So that was easy enough. So now from here, hold on. That's what I'm looking for. So then from here, if I plugged in 2, 2 squared is going to be 4 plus 6 minus 4, which is also going to be positive. So since that's positive, negative, positive, I know what my sign chart's going to look like. Now, doing on my number line, and I need to find out what my interval is. Now, looking at the, well, let me change that again. Looking at the actual polynomial, I'm able to tell. Looking at the polynomial, I'm able to tell what I really need. Now, looking at this polynomial right here, what you can tell is that this polynomial is less than 0. So since it's less than 0, then that means that it is negative. So since it's going to be negative, what we're concerned with is the negative intervals. So we're concerned with this interval right here. Now, what is that interval? That interval is all t that is in between 1 and negative 4. So that's what that is. So if that's the case, our solution set would be all values of t that's in between negative 4, which that's greater than negative 4 and less than 1. If in fact we're going to graph it, it's going to look a lot like this. We have our 0, I'll put 1 here, I'll put negative 4 here, and I will, that goes there, that goes there. Now notice this is the only negative part. And guess what? That is what we have on our number line. So really your sign chart already determines what the graph is going to look like. So let's do another example. See if in fact you can follow along. This one is going to actually have 3 roots. So let's go through it just to see. Now, you might be compelled to divide by x on both sides. Please do not do that. Dividing by x is not the actual way that you want to go about doing this. Instead, what you want to do is you want to make it a polynomial inequality, and you want to set this entire thing less than or equal to 0 or greater than or equal to 0, one or the other. What I'll do is I'll subtract 9x from both sides. If in fact I do that, I'm going to end up with x cubed minus 9x is greater than or equal to 0. Factor out an x. I have x squared minus 9 is greater than or equal to 0, which means x times x plus 3, x minus 3 is greater than or equal to 0. So now notice I have 3 roots in this problem right here. Then I would have to find my critical values. If in fact I find my critical values from here, it's actually rather easy. You just set this entire thing, x plus 3, x minus 3. You set this whole thing equal to 0. Remember, here we're trying to find our critical values. So then from here, you're able to say that x is equal to 0, x plus 3 equals 0, and x minus 3 equals 0. So if that's the case, our solution set is going to be, if in fact I solved all of those, our solution set is going to be negative 3, 0, 3, right? Now notice I put the actual numbers in order just to for a reason, because when I'm doing my sign chart, that's the order I'm going to put it in. So at one point I have negative 3, I have 0, and I have 3. So now instead of finding 3 sections, I'm looking for 4 sections. Now looking for 4 sections, I pick values. So let me change my color so that we could Let's do that. Over here, I'll choose -4. Here, I will choose -1. Over here, I'll choose 1. And here, I'll choose 4. So remember, I'm choosing values that's in between these numbers right here. All right. So based on that, I want to find out what's going to happen every single time I plug one of these in. Boom. If I do -4. So if I plug -4 in, I'm going to get a -4. -4 plus 3 is going to be -1. And then -4 minus -3 is going to be -7. Notice all that. That's going to be negative. The reason why that's going to be negative is because you have a negative times a negative times a negative. So from here, if in fact I plugged in -1, if I plugged in -1, the idea that you'll get here is you'll have -1. -1 plus 3 is going to be 2. And then -1 minus 3 is going to be -4. Right? So that's going to be positive. Just for the sake, I've done this problem, and I know that this, so for the sake of time, that's going to be negative, and that's also going to be positive. You can go ahead and check, but that's going to be negative, that's going to be positive. So then from here, you already have what your number line is going to look like and your interval. Now, looking at the actual problem, so looking here, you can tell what this polynomial has to be. That polynomial is going to be, it says it's greater than or equal to 0. So since it's greater than or equal to 0, then it's positive. So we care about the positive parts, and that's it. All right. So that means we care about this part here, and we care about this part right here. So since we care about those parts, we got to find out what intervals we're talking about. Now, mind you, notice that this is greater than or equal to. That means a lot right there. So since it is, we're talking about, from this case, we have x is, it's going to be greater than or equal to -3, but less than or equal to 0, right? And then this one right here is going to be, x is going to be greater than or equal to 3, right? So what do you think our interval is? Our interval, our solution set is just going to be all values of x such that x is between 0 and -3 inclusive, or x is greater than or equal to 3. Actually, let me change that up. Let me give you a better 3. And then I'll close that up. So when we're graphing that, it's going to look a lot like the sign chart. So let's get a 0 in here. Let's get a -3. Let's get a 3. Now remember, we just care about the positive parts. So the positive parts is going to look like from here to here. This was a positive part on the sign chart. And then from here on. So that will be the graph for this interval right here. And you guys got a couple more examples. So hopefully you guys are taking notes on this and this is helping you.